Hey guys, welcome back to my channel. The focus of this series is on structured query language, SQLs. In my previous video, I looked at the different ways you can use the select from statement. In this video, my primary focus is on the where clause that is used in the select statement. As I've explained previously, the select statement is used to display data from a table, and this was the compulsory part of the select statement, which was covered in my previous video. If you would like to find out more information about this, please refer to that particular video. Here, I will primarily focus on the where statement or the where clause. This is optional, and we generally use the where clause whenever we are wanting to restrict information. The where clause is or contains a condition, and in the next few slides, we will focus a lot on the types of conditions you can have when writing it up. We will focus on how to restrict numeric data in the where clause. We'll also look at how to restrict strings, how to work with dates and booleans. Then some attention will be given to the like operator. Thereafter, we will look at compound conditions. Compound, those are multiple conditions. And finally, we will conclude by using the in and between operators in the where clause of your select. So let's go. As I indicated, the where clause of your select statement contains a condition. Everything is based on a condition. So let's first try to understand how the condition works. We've been exposed to conditions in Delphi previously. You use a condition in an if statement. You also use conditions in a while loop. For example, you would say if num is greater than 10. So this would be a typical condition that you would use in Delphi. And that condition would either evaluate to true or to false, because that's what conditions do. They evaluate either to true or false. And if it was true, you would do a particular statement. If it was false, you would then go to the else part. That's how it worked in Delphi. Another typical condition that we would use if you had a string variable, if name equals Winnie. And take note that in Delphi, that when we used strings, we made use of single quotes. That's how we were able to reference our strings in Delphi. Let's look at how we make use of conditions, and in particular strings, in SQL. Well, the first point is that your conditions are exactly written in the same way as you would have written them in Delphi. So there's no change to writing a condition in Delphi versus writing a condition in your SQL, in the where clause of your SQL. And you will notice in SQLs as well, we can make use of the single quotes when working with strings. But we can also make use of the double quotes when we are working with strings. And when we are now going to work with our SQL statements, in particular, we are going to make use of double quotes. Let me tell you why we are going to use this particular option. When we take our SQL statement and apply it into Delphi, this is some of the code that we will be making use of. In particular, the code is going to be applied in this way, where this particular object uses a parameter called add, and that parameter is of type string. Now, because that parameter is of type string, we have to enclose it inside of single quotes. So if we're using single quotes for the parameter, then we need to distinguish between the quotes that are used in the parameter and the quotes that are used when we are referring to our string. So to differentiate the two in Delphi, we're going to make use of double quotes. So just take note of that. In subsequent slides, every time I refer to a string in the where clause, I will enclose it inside of double quotes, and you should understand the reasoning why this is being done. Let's look at how we work with dates. If you recall from the previous video, we had a table called TBL actors, and one of the fields was date of birth. So if you have a field that's of type date, you have to ensure that when referring to the date must be enclosed between a hash. That's one of the rules that we'll use when working with SQLs. A Boolean is true or false. It works in the same way as we would do in Delphi. And then all of these operators are available to us. We can check if something is equal to, greater than, less than, greater than or equal to, less than or equal to, and you can also check not equal to. Another operator that's worth looking at is the like operator. We know that when we use the equal to, we are looking for an exact match. That's how the equal to operator works. We're looking for an exact match. But sometimes we may not want an exact match. We want something that is similar. So in SQL, we can make use of the like operator, which allows us to look for patterns. We're looking for certain patterns, and these patterns could be similar to certain patterns that we are looking for. Let's look at more examples, and this will become clearer in terms of how it is used in those examples. But before we get to the examples, you should understand that when you use the like operator, there are two wildcards. There are two wildcards that are important. The first wildcard that we use with the like statement is a percentage. And a percentage could refer to 0, 1, or many characters. And we can use the underscore, not to be confused with the hyphen. This is an underscore. And when we refer to the underscore, that just represents a single character. Now, take note that these two wildcards are what you would use when you are writing your SQL statements and you are using them in Delphi. The same SQL statement can be run in Microsoft Access. So if you are running the same SQL statement in Microsoft Access, instead of using the percentage sign, which is what we use in Delphi, in Microsoft Access, you will use a star. And instead of using the underscore, in Microsoft Access, you will use the question mark. So these are just some subtle changes that you need to be aware of depending on what program you are working with. Also take note that the like operator is used whenever we are working with a particular field that is of type string. And remember that from the previous slide, all our strings, we're going to be working with them being in double quotes. So now let's look at some examples. In all of these examples, you will only see the where part or the where clause of your SQL, but understand that this where clause is going to fit into a select from. So if we had to say where actor name like A, and then we have the wildcard percentage. So this means that we're looking for some actor name that starts with the letter A, and then percentage means you can have one or more characters thereafter. Multiple characters can be used thereafter. So this will return all actor names starting with the letter A. Similarly, if you use the wildcard percentage and then you use an E, that will now return your actor names that end with the E. So the E is at the end of the actor name and anything can be in front of it. We could also have an example where we have a percentage with ION. That simply means it's ending with ION and anything before. Here is a wildcard where we're using the underscore. And remember that the underscore refers to a single character while the percentage was multiple characters. So this pattern is saying that the first character can be anything. The second character must contain the letter I, and thereafter you could have any other characters that could follow. But the second character in particular must be the letter I. So if we had to use a wildcard in that instance, it would pick up an actor name with Winnie, for example, because Winnie starts the second character with the letter I. In this particular example, we are stating that it must start with the letter A. It then has any other character, one other character, and thereafter anything can follow. What that tells us is that the actor name should start with an A and it must have at least two characters. You need to have at least two characters. Here, you may not see this very clearly, but there are two underscores, which means it's similar to the previous one, but it must have at least a length of 3 characters. And then the final example, it tells you it wants to start with an A, it's ending with an O, and anything in between. So that is a different type of pattern. So these are just some of the examples in terms of how you would go about using the various patterns when you are writing, when you're using the like statement in your where clause. Let us now focus on how to use compound expression. So if we are referring to compound, compound means more than one expression or condition, more than one condition. So whenever we use more than one condition, for example, we could say num greater than 10, then we say and name equals Winnie. This is how you would write a compound statement in Delphi. You will notice I'm making use of the single quotes. So here I am, this is how I would write my statements in Delphi. So there's two separate conditions, and we join the conditions using the AND operator. You could use different operators, either the AND, you could have a OR, you could also have a NOT. And each of these operators have priority. Just like when we perform arithmetic, you've got plus, minus, times, division. And when we perform this type of arithmetic, we follow the rules of BODMAS. So similarly, when we are using these operators, there's priority as well. First, you'll work out brackets, then you'll do the NOT first, followed by the AND, and then the OR. So if we look at this particular example, I've got a particular condition, I've got a second condition, and then a third condition, and these are all joined using these operators. So according to our priority, we know that you have to first perform this part because the AND has higher priority. So you'll take condition 2 and condition 3. That will evaluate to either a true or a false, because that's what conditions do. So here you'll get an answer. let's say the answer was true, you will then take condition 1, evaluate that, which will also then evaluate to true or false. And let's assume that was false. You will then take false or true, and that will then give you a final answer of true. So this is how you would apply your priority when working with conditions that have multiple operators. In the second example, you've got condition 1 or condition 2 and condition 3, similar to the previous one, except that we have brackets. And as you know, brackets always takes priority, in which case you will then evaluate the bracket. You'll get a true or false answer, take that, and you'll end it to the result of the condition 3 that you get. So keep in mind how multiple conditions work. So let's get straight into the use of the where clause. We've worked sufficiently in the previous slides with conditions. Now let's bring it all together. As I indicated previously, the where clause is used to restrict our data. We restrict it. From my previous video, we focused on this part where we said select column 1, comma column 2, depending however many columns you want from your table name, and that was compulsory. And that would return all the records. It would return all the records. But if you introduce the where, you are now restricting. You are restricting the number of records that are going to be returned, and your restriction is then based on the condition that you apply in the where clause. Let's look at some examples. All the examples that we are working with is going to be based on this table, TBL actors. And TBL actors has the fields actor ID, the actor name, actor surname, DOB, date of birth, the age, the cell number. Again, remember that cell number has a space between the two words, unlike any of the other fields, is local, and annual income. And these are the different data types. And we had 4 records in our table. So when I perform a particular query, the results that will be returned is going to be based on this table with these fields and these records that are in the table. So in the first example, I would like to display all the actor details. Display all the actor details. For actors that have an age above 20. So if we simply said display all the actor details, that would be very easy. We would say select star from TBL actors. This was explained in my previous video using the select from. But I don't just want all the actor details. I want only those actors that have an age above 20. So you can distinctly see a condition, a restriction coming into this particular example. So we will have our select statement that will be select star from TBL actors. And now we will introduce our where. And you then state the condition based on the field and what the restriction is about. Here we're looking at age above 20. We know that we had a field called age, so it's going to be where age above 20 means greater than 20. So that is the type of SQL statement that you would write. And if you run the particular SQL statement, this is what it would return. If you recall, we had 4 records in total. But because of the restriction, it's now giving us ages that are above 20, and there are only 2 records that have an age above 20. In the second example, display all the actor details for actors that have annual earnings above 75,000. Again, that is our restriction. We want the annual earnings above 75,000. So the where clause is now going to depend on annual earnings greater than 75,000. Very similar to the previous example. We would now say select star from TBL actors. Don't get confused here. I've written it on one line, and in the previous example, I've split it over multiple lines. It doesn't really matter. The main thing is we understand what the SQL statement is going to give us. So select star from TBL actors. That's going to give me all the records with the restriction now where the annual earnings, this is my field. Annual earnings, refer to my previous slide to understand all the field names in the table. So you've got annual earnings greater than 75,000. And what will be displayed in this case, again, of the 4 records, it's only 2 records displayed. This time it is Winnie and Tigger. And if you look at the annual earnings, you will see it is above 75,000. Let's look at more examples. In this one, display all the actor details for actors that have a surname, Pooh. So we are looking at the actor surname that is Pooh, Winnie the Pooh. So how would we write this particular example? In this one, select star from TBL actors. So there's no change to that particular line. What's our restriction? Here, the restriction is on the surname. So the field there is actor surname. And what value are we looking for? If the value equals Pooh. So we look, that will now generate Winnie the Pooh. And take note, we're using double quotes. It's double quotes for the reasons that I specified earlier. Although if you had to use single quotes and run the SQL in Microsoft Access, it will also work. But using the SQL in Delphi requires us to use double quotes. And I'm not displaying the result, but it will return just a single record with the details for Winnie the Pooh. In the next example, display all the actor details that were born after the year 1999. So immediately the field that we are querying is the date of birth. So we want the actor details that were born, who were born after 1999. So if you were born after 1999, it means it starts on the 1st of January 2000. So we want all the actor dates from the 1st of January 2000 onwards. So our SQL statement, select star from TBL actors, where we're querying the date of birth, that's my field, is greater than equal to, remember, I indicated when you are working with dates, you enclose it with a hash at the beginning and the end. And the format that I'm using, you could use a different format that could change, but in this format, it's the year, the month, and the day. And this is the 1st of January 2000. So this will return all the actor details who are born after 1999. Notice it's inclusive, which means from the 1st of January 2000, display the date of birth. And in that example, we get 2 records returned, Winnie and Piglet. And if we look at the date of birth, you will see both of them are born after 2000. In the next example, display all the actor details for actors that are local. You will recall there's a field called isLocal that was of type Boolean. So it becomes fairly straightforward where we say select star from TBL actors where there's the field isLocal. Because it's Boolean, I check to see that it's true because all local actors had a value of true and the foreigners were not ticked, so those would have had a value of false. In the next example, display all the actor details for actors whose name starts with the letter S. So the names start with the letter S. So immediately you should realize this is not an exact value. This is a pattern that we are looking for. It starts with the letter it starts with the letter T, and any other character can follow. So you expect the like operator to come in. The answer to this would be select star from TBL actors, where we want the name to start with T. So it's based on the actor name, and the actor name is like. So we're looking for a pattern, and the pattern we're looking for is T it starts with, and anything else to follow. It starts with the letter T. And if we run that particular one, it would give us Tigger, because the actor name is the only actor starting with T. And if you recall from my previous note as well, if you were running this particular SQL statement in Microsoft Access, make sure you use the star and not the percentage sign. The assumption here is that these SQLs are going to be running in Delphi. In the next example, I'm looking at the names that end with the letter E. Give me all the actor names that end with the letter E. And you can pretty much work that out. You want a percentage followed by the E. And there it is. Select star from TBL actors where actor name like, right, like. And percentage E means anything before but must end with an E. And when you're using the like, it's the operator that is like, and we don't use an equal to with the like operator. And when you're using a like operator, you expect it to use either the percentage wildcard or the underscore wildcard. And for this particular case, actor names ending with E, we've got two of them, Winnie and E-O, both actor names end with an E. More examples, display all actor details for actors whose name contains a T. So we are not interested in whether it starts with a T, ends with a T, but it could be even in between, but it must contain a T. And the pattern that we are looking for is having a T, anything before, anything after. It will have a T in it. And in this case, we've got a T in Tigger and we've got a T in Piglet. So there are two records that will be returned in this case. Display the actor details for actors who is on the 083 MTN network. Okay, so that works on the cell number. We've got a field called cell number. Remember, there was a space in that field name, cell number. And from my previous video, you know that when a field contains a space, you need to refer to it using square brackets. And there we are. Where cell number, there's the square brackets, like, and I want the pattern 083 with anything else that follows. In the next example, we're looking for actors who were born on the 16th of August, and we are not concerned about what year, but it's an exact day and month. So we're working with the date of birth. That's the field, date of birth, and sorry, that was the output for the previous one who was on the 083 network. In this particular example, look at how we use the date. We are saying where the date of birth is like, and this is where the percentage is, and the rest of it is fixed. The 08/16. And because we are treating it like a string, you will notice that I did not make use of the hash. I've not enclosed it between a hash because like works on a string and I'm treating it like a string. So that works. And if you run that, then you will find that we've got Tigger, who's born on the 16th of the 8th month, which is August, and the year was 1995. Another example, we're looking for somebody whose name has the letter I in it. It contains an I, whose name has an I in the second letter, sorry. The I is contained in the second letter. So we use the wildcard, which is the underscore. That's your first character. I must be in the second character, and anything else can follow. And in that case, you will see in the second character, we've got 3 actor names that start with the letter I. Winnie, Tigger, and Piglet all have the second character starting with the I. And just another reminder, if you are using this SQL statement in Microsoft Access, instead of using the underscore, you will make use of the question mark. And if you had to use the star, if you had to use the percentage rather in Delphi, in Microsoft Access, you will use the star. Now we're looking for a name that starts with the letter E and ends with the letter O in the 4th character, very specific. So there we are. This is 1, 2, 3, 4. So I've got 2 underscores. It's starting firstly with an E, 2 underscores, and then you can see the O is in the 4th character, and anything else can follow. And you can guess what that answer is, E or, that has that particular combination for the actor name. Now let's look at how to deal with multiple conditions. We're looking at multiple conditions, and here you have your condition, operator, condition, operator. Similarly, if you are using an or, and for that matter, you could use a combination of, which is also allowed. Remember the priority that we spoke about. And if you are using the not, then this is how you would go about using the not. And please take note, whilst there's a semicolon there, that should not appear when we are writing our SQL statements and using them in Delphi. A couple examples that make use of multiple conditions. So here we have an age above 20. That's quite straightforward. We want the age above 20, but below 40. So we want the age above 20, and we also want the age below 40. So those are our 2 conditions that we want to use. It needs to be greater than 20, and it needs to be less than 40. So we need to join those 2 conditions, select star from TBL actors, where age is greater than 20, condition 1. There's my connector, and age is less than 40. Make sure you fully understand how to use and or. That will be explained in another video. But in this case, I want both conditions to be true. In other words, age greater than 20 and age less than 40 for it to be within the specified range that we are looking for. And in this case, we've only got one actor in that range, who is Tigger, who has the age of 25 years. In the next example, we are looking for earnings above 75,000 and below 130,000. So very similar to the previous one, but this is based on annual earnings. So I've got the annual earnings greater than 75,000, says above. And then annual earnings below would be less than 130,000. And we want both conditions to be satisfied. So we connect it using an AND. And again, returning this, interestingly enough, it's also Tigger, who happens to have earnings of 129,000. In the next example, we want actor details who were born after the year 1999. We looked at how to solve that particular example, how to write that condition, and not and, or they earn above 100,000. So this means we can have one of the two conditions to hold true. The first condition is either you're born after this date or you earn more than that amount. So that's now connecting the two conditions with an or. And you will see the date of birth as we did in the previous example. The date of birth is greater than 2000/01/01. We enclose it between a hash. We're not using a like as we did in the previous example. This is a date that we are comparing. You enclose it with a hash. And we want the annual earnings greater than 100,000. And we want one of the two, therefore we use the or operator. And that returns 3 records, Winnie, Tigger, and Piglet. Let's look at how you make use of the not operator. So here in this example, we want to display actor details for actors that are below the age of 50. So that is our restriction, below the age of 50. If I look at this particular restriction, it's greater than, the age is greater than equal to 50. Not age greater than equal to 50 will be the opposite, where we have age less than 50. And that will meet the requirement where the actor's age is below the age of 50. In that instance, our output is Winnie, Tigger, and Piglet. And if we look at all of their ages, we see it is below the age of 50. Display the actor details for actors that are foreigners. We can use not in a similar manner. The opposite of foreigners are locals. So we could select star from TBL actors where is local equals true. That means they are a local. And not means simply is local equals false. And that would then display all the actors who are foreigners. And you'll notice there are no ticks. That means that they are foreigners. I guess a more appropriate example where we could use the not, the example that comes to mind in Delphi, if we are trying to find the consonants, and you have vowels, they make up the 26 letters of the alphabet. There are only 5 vowels, so to determine the consonants, and to look for 21 different alphabets would be quite time consuming. It would be easier to rather look for the 5 vowels and use not, which would then give you a consonant. That is probably a more appropriate example where you can use the not operator. Let's now look at how we could use in and between operators. Here we use the select from, where the field is in, and we define a particular set with the values that we want to check within the set. Some examples: display the details of all the actors with the surname Pooh and Pig. So we want those surnames. We could say select star from TBL actors where actor surname in, and we can list the values that we want the actor surname to be. This, you will notice, is similar to making use of the or operator. In other words, we could have said actor surname is equal to Pooh, or actor surname is equal to Pig. That would be your equivalent instead of using the in operator. In the next example, display the details of all the actors that have an annual earning in the range 50,000 to 100,000. So this is a range. This is where we can make use of between, and we select star from TBL actors where the annual earnings, which is what we want to check, between, and we specify the range between 50,000 and 100,000. That is how you would use the between operator. And in that case, you would then get the range of 70,000, which falls within that range, and Piglet is the only one in that range. And for the between operator, that is similar to using the and operator. So we could have said where annual earnings equals 5,000 and where annual earnings is greater than equal to 5,000 and annual earnings less than equal to 100,000. That would be the equivalent instead of using between. Another example where we could use between, display the details of all the actors that were born between these dates. Again, the minute we're working with dates, you should be thinking immediately, I need to enclose these dates between a hash. So we select star from TBL actors, we're checking the date of birth, that is the date field, between, and we have the first value, and we have the second value. Both are dates, and both are enclosed between the hash characters. So here there seems to be an error. It should be, we want it between the dates 21/10/1990. Oh, it's just the other way around. There it is, 21/10/1990 and 21/10/2010. So there it is, 21/10/2020. So this is how you would use the between operator when working with dates. And if you look at all those date of births that are within that range, this is what you would have within the range 1990 to 2010. So this concludes how we make use of the where clause in a select. It's used for restricting information, and There are many different data types that it can be used on. Make sure you revise the different data types. I hope this video helps. Till the next time, bye.